Okay, so today it's all about these rational graphs or key features of these rational graphs. So a rational graph is one that has x in your denominator. It's also called inverse graphs. And if you were to graph the basic one, we were supposed to do that in Math 2, but we got all kinds of confused this past year in Math 2 with our snow days. But if you were to graph it, it ends up making two curves. And it's two curves that never cross in opposite quadrants. But you actually don't need to know that to solve these problems. So this is the one that we are going to look at on the calculator, and this is the only one that we're going to look at on the calculator because everything else we're going to find by hand. But if you want to graph them on your calculator later, you can. I just don't want to use that time because finding it by hand is probably just as simple as trying to graph it. So if you would go to your graphing calculators and let's just refresh on how to write this in because it took me a minute to remember how to write it in like as a fraction. So remember there's a shortcut button on your calculator that will allow you to write it in. If you hit alpha y equals and then go to the first one, it makes that fraction horizontal for you. And I know we talked about that in Math 2 and I have kind of forgotten to bring it up in Math 3 because it's a newer feature that I keep forgetting about. So our equation was x squared plus 5x, no, minus 5x over x minus 5. So you can just move your cursor around and you can type it in. Now, if you don't have that feature in your calculator, you have to use parentheses and you put the top in parentheses, then divide and put the bottom in parentheses because your calculator needs to follow order of operations. So if you forget, make sure your numerator's in parentheses, make sure your denominator's in parentheses because we're dividing the whole fraction together. So now that they're in parentheses like that and they're written out, we are going to go through and graph them. I'm going to clear that one out though because you guys don't need to see it. And go ahead and hit graph. Did you expect to see a line? No, I wouldn't expect to see a line either, and you might can see this a little bit better on mine. It almost looks like a consistent line, but if you look way over here in this first quadrant, it breaks. It has a gap, or what we call a hole, also known as a point of discontinuity. Discontinuity means that you can hold your pencil and make that, but in order to get this gap here, I'm going to have to pick up my pencil, right? And then put it back down and keep going. Yes, it is actually similar to our restrictions that we have. I was going to try to go over and zoom in on it, so I'm going to try again. Let's see. 4 to 6. Zoom 0. There we go. All right, this is from 4 to 6, so you can see it a little bit better. You can see that gap there in the middle. All right, but again, that's the only one that we are going to graph, so just add this to it. This graph has a point of discontinuity at x equals 5. So this graph has a point of discontinuity at x equals 5. And another way that we can see that is what happens if we plug 5 into this equation. The denominator equals 0, right? And thou shalt not divide by 0. So we actually don't have an answer if we plugged in 5. That answer is missing. But any other numbers that we plug in for x will work. So just 5 will not work because it makes us divide by 0. So points of discontinuity are also called holes or vertical asymptotes. Remember how we talked about horizontal asymptotes before? Those are those horizontal lines that exponential graph didn't cross or touch. Remember, we made it as a dotted line when we graphed exponentials. Well, now we have vertical asymptotes, which is a vertical line that your graph will not touch or cross. Now, this particular graph that we just graphed on our calculator didn't have any vertical asymptotes, but it had a hole. It had a gap. And so both of those are called our discontinuity points. All right, your next set of notes I have typed up for you that I'm going to give to you so you guys do not have to write down all of this information right here. I printed it for you so that way you can use it as a reference. Now, you cannot use this on your test, so you need to make sure you memorize it by next week when we take our test. Once you get your slip of paper, you might want to write those words that I have written to the side, the unfactored form and factored form. You're welcome. There you go. So, to the side, the first two need to be an unfactored form to figure those out, or it's best if they're an unfactored form to figure those two out. And then the last four, you really need it in factored form to figure out those last four parts. So we are going to find these 6 key features for these problems. So it's not like the same key features that you guys find when we're looking at graphs. Normally we find 9 things, right? We add on some range and intervals of increase, decrease, all that kind of stuff. So for this, we're not going to do that. We're going to find these specific 6 key features. And when you take quizzes and tests, I kind of label them out for you. So you don't have to remember what order they are, but you do need to memorize how to find them. So when we look at horizontal asymptotes, we look for the highest power, which is also known as the degree. So you might notice on your paper I wrote degree, but degree is the highest power. So remember how we name them, like quadratic, quartic, or whatever. So you're going to look for your highest power in the numerator and highest power in the denominator. If the numerator is bigger, you say none. If the denominator is bigger, you say y equals 0. And if they're the same, you divide their leading coefficients, which means you divide the numbers in front. And we're going to do examples of each as we go through. For the y-intercept, well, you guys all know what a y-intercept is, right? It's where the graph crosses the y-axis. Good. So if it crosses the y-axis, what is the value of x? 0. And so that's why it says plug in 0 for x and simplify. When x is 0, that gives us our y-intercept. Now the next 4 things, factoring is the best. For domain, it's all real numbers except what makes the denominator equal to 0. So this is the same thing as finding the what? Restrictions. That's what it's called. Finding our restrictions. So domain and restrictions are pretty much the same, but we're going to use that funny looking R at the beginning. So we're going to say all real numbers and then say x cannot equal da 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 da. Now zeros are the same thing as x-intercepts. So what's going to make a fraction equal to 0? When 0 is on the top, right? 0 divided by any number is 0. So that's why on this one, it says to simplify first, then set that numerator equal to 0. Now, I added an extra line on your paper. Simplify means to factor and cancel out. So remember how last week I said if you factor everything, then you can make at least a 60? You got to factor again. So factor every single thing. Okay. And then once you have simplified and canceled out, then you're going to take that numerator and set it equal to 0. That will tell you what your x-intercepts are. For vertical asymptotes, it's very similar. Instead of the numerator, we set the denominator. Because remember, that is like our holes or the vertical lines that the graph doesn't touch. So that's why we use our denominator, because that's kind of like our restriction again. What can x not be? But now it's after we simplify. So it's not the whole problem. It's just at the very end. And then holes, that's what we set that cancels out equal to 0. And then solve that for x. So if you notice all of these here at the bottom, they are also all x equals values. Now, domain is usually x cannot equal, but all of those we're solving for x. Solve for x, solve for x, solve for x. What makes that denominator equal to 0, which is going to be another x. And then these two up here are y equals, because we're trying to find the horizontal asymptote, which is that horizontal line, which is a y equals line, and the y-intercept, which is also y equals. So let's go through, I think I have 5 or 6 problems for us to do. So let's start very simple with number 1. I'm going to go with yeah. Like the key features of the graphs? Yes. Just less parts. Now this A, B, C, D, E, F is always in the same order. This is the same order that I use every time on tests, quizzes, homework, notes. So if you want to write it one time what each of them are, then that's fine. Or if you want to write it every time, then that's fine as well. Okay, now let's look at our little slip of paper and let's start. So first we want to look for the degree, which is the highest power. Now remember, it's the highest power on the variable. So does the numerator have a variable? No, so that power would be 0 if it doesn't have a variable. Does the denominator have a variable? Yep, and the power on that variable is 1. So what's bigger, the top or the bottom? The bottom. X is bigger than no x. So it says if our denominator is bigger, what do we write? Y equals 0. So the denominator having x is bigger than just 1. So y equals 0. All right, now for y-intercept, it says on our paper, plug in 0 for x and simplify. This is what I like to do, and you can do this to the side if you want to make these look a little bit better. But I start over here and I say y equals like the equation, and anywhere there is an x, I put a 0, because I'm going to plug in 0 for all x's that I have. Yep. And then simplify it, so we get 1 on the top, and 0 plus 1 is 1, and 1 divided by 1 is 1. So my y-intercept is y equals 1. And don't forget to put the y equals at the front. Don't just put 1. You want to put y equals 1, because I will count off if you don't put the right variable with it. Now, this was unfactored, right? And so for the rest of these, we want to factor it. Can I factor either of those parts? No. So sometimes your unfactored and your factored are exactly the same thing, and that's okay. So our domain. When you talk about domain, you start out with this funny looking R, and then we say x cannot be. So it's all real numbers except, and we tell it what x cannot be. What can x not be in this problem? -1, because that's going to make our denominator equal to 0. And you can even do that scrap work to the side as well. X plus 1 equals 0. So x would equal -1. You will probably see on my paper, well, maybe sometimes, looks like I didn't do it a whole lot, but you'll see on my paper, like I put everything on the left column, and then I have some scrap work just written over here to the side that I try to do. All right, x-intercept. Let's look at our paper. It says simplify, then set the numerator equal to 0 and solve for x. So we talked about how this is simplified as much as possible. What's in my numerator? 1. If I set 1 equal to 0, can I solve that for x? No, it doesn't have an x in it, right? So this doesn't work. So are there any x-intercepts? No, so we say none. So if you get a problem you can't solve for x, just say none. Yeah, so in the numerator is only 1, right? When I set 1 equal to 0, does 1 equal 0? Can I solve that for x? No, because there's no x in it. None. Now, VA. VA is to simplify, then set the denominator equal to 0. Well, we already did that, right? X plus 1 equals 0, so x equals negative 1. So this is the point where we don't put not equal to, we put equals. So at negative 1, we have this imaginary vertical line that the graph will not touch or cross. Okay, and last we have holes. Now on our paper it says set what cancels out. Did anything cancel out? No, nothing can cancel out here. So do we have any holes? No. So we say none. And the more that we do, the more this will become clear. But this is a very simplified, already kind of factored problem. All right, so let's try another one. You guys write down number 2 and then A through F. Now, first off, we're going to start. It's in unfactored form. We don't have any parentheses, right? That's what I mean by unfactored form. Maybe you might want to think about it as standard form as well. So nothing's factored. We're going to leave it like this. And let's start with HA. So in HA, it says, look for the highest power. Which is bigger, our numerator or denominator? Definitely. If the denominator is bigger, we say y equals 0. Good. For the y-intercept, yes. It tells you on your paper, you say none. Now, for y-intercept, we plug in 0 for all the x's. Now, let's talk about this while you guys are plugging it in, okay? What is 0 to the second power? 0. What is 0 times any number? 0. So, any term that has x, just put a 0. Because 0 times anything, 0 to any power, is still going to be 0. So don't feel like you have to put 2, then 0 squared, then 5 times 0. Because 0 to any power is 0. 0 times any number is 0. So any term with x, you put it at 0. And then you simplify the numerator and simplify the denominator. So my numerator I have 1, and my denominator I have. And if we simplify that and make it a little bit prettier, what's 1 divided by negative 7? Almost, negative 1/7. Keep the 1 in the top, yep. So y equals negative 1/7. Do we usually see a negative in a denominator by itself? No. You usually see it in front of the fraction or with the numerator. Okay? Any questions so far? Now, to do the next 4 pieces, we need to simplify, which means that we need it in factored form. Can I factor the numerator? No. So just leave it as 1. Can I factor the denominator? Possibly, right? It's a what? Long trinomial. How do I start my long trinomial? Good. And this is why I have this extra room to the right side of my paper. I'm doing all that extra work over here, and I'm just writing my answers down. So we multiply our 2x squared times negative 7, which gives us, which equals blank times blank. And then it's got to add to be 5x. Now, for those of you who don't like to mess up the paper that you're turning in, if you want to put all your scrap work on a separate sheet of paper, then that's fine. But I would put a big box around it and put the problem number, like number 2 in the corner. So that way when I'm looking, I see that you have some work and you just didn't copy somebody's or come up and copy the answer key. That's a no-no anyway. All right, what multiplies to be negative 14 and adds to be 5? Perfect. And don't forget, those go back in for the middle term. And now we have 4 terms, so now we use our grouping. Group the first 2, group the last 2, and look for the GCF. So 2x and 7. Very good. They are. And then we take those GCFs out. Remember, we're dividing it out of each term. And what are we left with? X minus 1. In both cases, when I take out that GCF, I'm left with x minus 1. So this will factor to be good. So factoring long trinomials is very helpful when you do this, and when you take your test next week, you need to make sure that you know how to factor all the different types, because I'm not going to come over and tell you how to factor because that's part of the problem. So you need to make sure that you know how to do GCF, difference of squares, short and long trinomials. All right, now that it's all factored, can we simplify and cancel out anything? No, nothing's the same. So that's as factored as much as it goes. So now we're on part C, which is our domain. So let's look here. It says all real numbers except what makes that denominator equal to 0. So we have all real numbers, x cannot equal. So let's take what's in our denominator. Now we have 2 parentheses. We set them both equal to 0 and solve for x. Very good. And I just left that one as a fraction, so I'm going to say negative 7 over 2, but negative 3.5 works. It doesn't matter to me if you write it as decimal or fraction. So x cannot be negative 7/2 or positive 1. Pretty much everything that you factor, you're also going to set it equal to 0 and solve. So keep that in mind. All right, now x-intercepts. If we look in our paper, it's we simplify first, which we have done, then set the numerator equal to 0 and solve for x. Well, what's in my numerator? 1. Does it have an x with it? So what do we say? None. There's no x in the numerator, so just say none. Remember, VA is pretty much the same, except now we look at the denominator. We already took our denominators, set them equal to 0 and solve. So x equals good. And I don't know why I put x equals again for the second one. You could have just put comma 1. I just kind of kept going. So those are those denominator pieces. Okay. Now wholes. On here it says set what cancels out. Did anything cancel out or reduce? Nope. So we say none. I promise we'll get some canceling out soon, but that's how we're going to start these. So on this one we had to do a little bit of factoring, whereas the first one we didn't have to. Let's try a third problem. This one's definitely going to have some work for us to do. Yay, math. Sorry. Okay, let's start with HA. So look for the highest power of the degree. What's the highest power in the numerator? It's the x squared, right? It's the 2. What about in the denominator? Almost. No, it's got to be a number. So they're both x squared, right? So on here it says if they are the same, you divide the coefficients. What are the coefficients? It is. Coefficients are what, though? Yep. Well, what does it mean to be a coefficient? That's what I'm looking for. The number in front. So what's in front of my x squared on the top? 1. What's in front of my x squared on the bottom? 1. And 1 divided by 1 is 1. So it's y equals 1. So if they're the same, you divide them. Now, you can also do that over here to the side. You only divide the highest term. So the highest term in the top is x squared. The highest term in the bottom is x squared. You could also divide them with the x squareds in there. So what's x squared divided by x squared? 1. Because they just cancel out, right? It's like saying 5 divided by 5. Still 1. Okay. Now, next, y-intercept. What do we do for y-intercept? Plug in 0 for all the x's. So anywhere you see an x, put a 0. And then you simplify. So on my top, I've got 0 plus 0 minus 6. And on the bottom, 0 minus 0 minus 2. So on the top, I'm left with negative 6. And on the bottom, I'm left with negative 2. Which simplifies to 3. I know it's kind of simple to see those, but it's actually a really good idea to write it out, as you will see in some problems that we do later. Now, A and B are the unfactored version, the standard forms. So C through F, we need to factor it, right? So what do we have in our numerator? Short trinomial. So let's figure out what multiplies to be the last and what adds to be the middle. So we have a negative 6 and a positive 1. Positive 3 and a negative 2 will work. Those can go straight back in your parentheses. So x plus 3, x minus 2. The denominator's the same, right? Short trinomial, do your scrap work. What multiplies to be negative 2 and adds to be negative 1. So x minus 2 and x plus 1. Now we could do what? Cancel out what? X minus 2. Our x minus 2's can cancel out and go away. Let me use a highlighter for that so we can still see through it pretty much. And so we are left with, now think about that Red Rover game. Can I just cancel out those x's and say my answer is 3 over 1? No. Remember how we talked about Red Rover, about how they're locked together? If you see a plus or a minus, it's holding on tight. You can't break them up. So you can't break up those x's. Your final answer to simplify is just x plus 3, x plus 1. So if we were doing the homework from last week, that would be our final answer, right? Okay, but let's go through and answer the rest of these. So domain is all real numbers except what makes our denominator equal to 0. Almost. Negative 1 definitely, right? Negative 1 definitely from this. And there's another one, which is 2. Because even though it canceled out, it was part of the original denominator. So when you do this part right here, you're looking for part C, domain, you're going to look right here at the factored version, not at the final. Okay? Just like with our restrictions that we did last week. All right, next on our list is x-intercept. Where do we look for x-intercept? In the numerator. Now, which numerator? The factored or the simplified? What does your paper say? Simplify. Your paper says to simplify then set the numerator equal to 0. So it's kind of like that simplified final answer. So what's in my numerator? X plus 3. So we're going to take x plus 3, set it equal to 0, and solve. So x would equal negative 3. So a lot of people kind of forget that last step, and they like to write on the paper x plus 3, but I'm not looking for what's in the numerator. I'm looking for once you solve it for x. All right, VA. What does it say about VA? Simplified version. So we're looking at our final answer, and what part of that final answer? The denominator. So what's in my denominator? X plus 1. Now again, don't forget we need to set it equal to 0 and solve it. So x would equal negative 1. Now we have the last part, which is the wholes. What does it say on your paper about the wholes? And what canceled out? X minus 2. So we set that equal to 0 and solve. So x equals 2. It's pretty when it's color-coded. Ta-da! So those are the different spots that you look at. But if you know and understand what this paper says, you can find those different spots. So what's factored for part C for domain, the simplified version for D and E, numerator for x-intercept, denominator for VA, and then F, wholes, what cancels out. All right, so let's do a couple more. Make sure that we got this. Now we got the ball rolling. Now this is fun, right? It's like a little puzzle. Do you want to just solve it? Okay. No math nerds like me. All right. Question 4. This is our next to last one, you guys. This one and one more. Correct. But you won't have any division problems within this. Yeah, I would just give you the 1. Okay, now on this one, I'm going to tell you something a little bit different to do here to start, okay? And that might make it easier for the rest of it. Now, normally on the front part, I said leave it in unfactored form, right? But really unfactored kind of means standard form. Is that numerator in standard form? How would I get it in standard form? Yep, and how do I rewrite this? Negative x plus 3. So if you want to rewrite it in standard form, then you can before you get started. It kind of puts the variables in a better order to help us figure out the degree. Correct, but we're going to do that next. So don't factor out that negative 1 yet, but yes, we will do that. All right, so step 1, look at your paper, HA, what are we looking for? The degree, we are solving for y. What's the degree of the top? It's just an x, right? So it's a 1, x to the first power. What about the bottom? To the second, which one's bigger? The denominator. What do we say if it's the denominator? Perfect. Okay, now y-intercept, tell me how to find it. So anywhere there's an x, I put a 0. Doesn't matter if it's a negative x, I just put a 0. Anywhere there's an x, that whole term becomes 0. Because we can't say negative 0, right? Making no sense. All right, so what's the top part? 3, and the bottom part. And that can reduce to... So much enthusiasm there. Negative 1/3. And don't forget the y equals when you put it down for your y-intercept. All right, now we're on to the tougher part, because for the next 4 things we need to do what? Factor. And Izzy told us we need to factor that numerator by taking out a -1. If the first term is negative, you always take out a negative, and when I do, it's going to become x minus 3. So take out that GCF. First term's negative, take out a negative. The bottom's a difference of squares. How's that factor? Very good. And you may notice there are some like factors there that we can, and those are, so I'm left with very good. Now, for the homework, I tell you guys to simplify. So this is the answer that I'm looking for when I say simplify, okay? And on tests and quizzes, if I say simplify, that's what I want, the simplified answer, okay? All right, so now let's do domain. So start off with a funny looking R. All real numbers except, where do we look for domain? Denominator. Domain, denominator, so close to each other. And remember, what part of the denominator do we look for? What part of our answer here? Yep, the part right before you simplify, looking at that factored part right here. So we have all real numbers, but x cannot equal -3, +3. Yep. So it's that denominator that we have there. All right, then next we have, I don't know what color I used next, I think it was green. Next we have x-intercept. Where do we look for x-intercept? Simplified, so that's that final part, and looking at the top or the bottom? It's the top. It says simplified numerator. Is there an x in my simplified numerator? No. So what do I say for x-intercept? None. If the x is gone, can't do anything. All right, VA. Where do I look for VA? Or denominator, right? Of which part? The simplified. So it's the final denominator, which also is part of the domain. But x equals -3. So remember, we take what's in that denominator, set it equal to 0, and solve. Now last we have the wholes. Where do we look for wholes? What canceled out? So what canceled out was, so if we solve it for x, x equals +3. This is another helpful hint for you to look for, and you can look back at the other problems. Whatever you put for domain, you will put for VA and wholes. It may be that you put it for both, or you may put it for one or the other. But every problem that we have done deals with the denominator, right? VA is denominator, domain is denominator. Wholes is what cancels out, so it was originally in the denominator. That's right. Domain is E and F. So if I look back at this one, -1 and 2, that was domain. When I look at this one, the same thing we put for the domain, we put for VA because nothing canceled out. And it was the same with problem number 1. All right, let's do our last one here, number 5. Anybody ever seen that movie Short Circuit about the robot Johnny Five? No? Oh, it's a good little 80s movie. Maybe 90s, late 80s, early 90s. You can start it, but there's a little trick to it. Oh, yeah. I watched some of it, not as much as I guess my older brother did. I was more raised on Care Bears and Rainbow Bright. Rainbow Bright was my fave. Sparkle. I actually bought a Rainbow Bright cup yesterday at Cracker Barrel. Okay. Care Bears, my favorite. I loved when they introduced the cousins. That was cute. I liked the raccoon. Oh, yeah, that one's fun. All right, anyway, back to math. Let's finish this up so you guys can get to homework. So HA comes first. So looking for the degree. What's the degree of the numerator? What's the bottom? 1, right? So the degree is the power. So the degree of top is 3. The bottom has power of 1. Which one's bigger? So if we says the top's bigger, we say none. Okay? So numerator none, denominator 0. Those kind of go together, right? Numerator none, denominator equals 0 for restrictions. That's kind of how I remember it. And if they're the same, we divide them. Okay. Now, y-intercept. This one's a little tricky with the y-intercept because we said before, any term that has an x, we replace it with a 0. So on top we have 0, but on bottom we have 0. Is 0 divided by 0, 0? Type it in your calculator. It's in A. It doesn't work. So guess what this is? None. Thou shalt not divide by 0, folks. Thou shalt not do it. The math police will come and get you and put you in math jail. It does, doesn't it? So, yeah. So, wouldn't that be fun? So, remember, it's okay to say 0 if 0 is on the top and there's a different number on the bottom, but it's a no-no if there's a 0 on the bottom. Okay? This does not work, so we say none. It's undefined. It's not an answer. So it's okay to say 0 if 0 is on top. It's a no-no if 0 is on the bottom. All right, now to do the next few things, we have to do what? Factor. You can factor that numerator because you can take out a what? An x. So close. And what are we left with? Can I factor that denominator? No. Can I simplify? Yes, you can. Let's look at, I'm just going to pull this to the side so that way you can see it better. If I ignore the parenthesis, it's x over 3x, right? All of that's multiplying. So can I reduce this or cancel something out? The x's, that's right. So on this particular problem, this x and this x can cancel out. So I'm left with x squared plus 3 over 3. Can I cancel out the 3's? Because on top it's locked together, right? The x squared 3 is locked together, so you can't cancel those out. So this is my final answer. So be careful on that. If you have monomials at the front or GCFs at the front, they can reduce. Okay, so let's go through with our domain. It is all real numbers except, now let's set it equal to 0, right? Domain is denominator. And in that original denominator that we have a 3x that doesn't factor, so we have to look right here before we cancel out. Set it equal to 0, and x cannot be 0. So we have all real numbers except 0, because 0 times 3 is, and thou shalt not divide by, we're going to fix you soon, you guys. Okay, let's see. Now we have x-intercept. Where do we look for x-intercept? The simplified, so that's our final, top or bottom? Top. It's simplified numerator. Now this one's a little tricky. Let's take that one, set it equal to 0, and solve for x like it tells us on our paper. We simplify, set the numerator equal to 0, and solve for x. What would you do to solve for x? Subtract 3 and square root. You do get an I, and don't forget anytime you take a square root, you have to put a plus or minus. Now, can we take the square root of 3? No. So this is actually plus or minus I square root 3, but don't write it in that blank because I means it's what? Imaginary. Can we see imaginary? No. So if I say, my x-intercept is my imaginary friend right here. His name's Sam. Y'all are going to be like, Miss Cook, you've lost your mind. So if y'all put an imaginary number here, I'm going to say, you've lost your mind. I can't see it. So our x-intercept is not visible, so we say none. So when you get an imaginary number, you don't have to simplify and break it down, but you might get a square root that you have to leave like this for one of your answers. That's not imaginary, okay? Yes. So if this was a positive 3, you would say x equals plus or minus square root 3. Yep. That's right. So what's in our simplified denominator? Can we solve 3 for x? So what do we say? None. Now we have wholes. Oh, well, what is wholes? What does it say on our paper? What canceled out? X. That's right. So this would be x equals 0 because that's what canceled out. Because don't forget that little trick I just told you guys. If you put it for domain, you're going to end up putting it for VA or wholes eventually. All right. Now, your homework, make sure you did what we did in our notes. So your homework is problems that are on Canvas, and so there are 16 of them. Some of them go by really quickly, though, and some of them you might have to show some work for. You might end up factoring some of the same things multiple times. But you got 16 problems for homework. You want to do them just like we did our notes. And then I don't have enough days to give us a quiz in this unit, so I'm giving you a take-home quiz. Y'all might have noticed it over here on the board. But it is due on Monday. There's only 6 problems. So you can do 1 a day. You'll have to do 2 one day. But you can definitely get it done pretty quickly. If you know how to factor, this might only take you about 30 minutes. But if you struggle with factoring, it could take you a little bit longer. Yes, you can. Now, also due on Monday is your projects. You can go. Is your projects that you have. You're welcome. That you guys got on October the 13th is when I gave it out. So you've had over a month on those. So hopefully you've been working on your big project for second quarter because those are due on Monday with the bonus stuff. And our next test will be a week from today, so next Wednesday. Any questions? Don't forget to also, I gave you guys a progress report. Get that signed and turned back as soon as possible.